Oopsie, made a mistake. Case 6, concave mirror, object between F and the mirror. Final case. We draw the first standard light ray to help us locate the image. This light ray comes from the object's head, bounces off the mirror, coming from the object's head parallel to the principal axis. We know it's going to reflect through the focal point. Again, we can't use our second standard ray because we can't go from the object's head through the focal point and come back parallel. We can't because we're in front of it now. So we need to use our backup ray, the third important ray, and a light ray headed towards the mirror as if it came from the center of curvature. A light ray leaving the object's head as if it came from the center of curvature is going to hit that mirror head on and bounce straight back through the center of curvature. And I'm gonna tweak my diagram a little bit because it's not as pronounced as I want it to be. Notice the reflected rays this time, are they converging? Are they going to come together and form a real image like those earlier cases? No. Are they parallel? Is no image going to be formed? No, that's not the case either. What are the reflected rays doing this time? Diverging. And what do diverging rays always produce? Virtual images. You go, Dorothy. So if I put my eyeball here and I caught those light rays, my eye would be totally faked out. Where would my eye think that those light rays came from? Well, I extend them backwards. And I extend them backwards with dotted lines because there really is no light back there. And where they intersect, that's where my eye would think the light came from. The light really came from the object's head. And my eye would think that the light came from here. Since there really is no light behind the mirror, I draw the image with a dotted line. And once again, I'm doing the simplified version of these ray diagrams. And if the feet start off on the principal axis, then the feet of the image are going to be on the principal axis, and there you have the image produced. So that right there is the object. This here is the image. And Dave, what's one characteristic of this image? Virtual. Yo, what's another characteristic? Bigger. Dorothy? Upright. Now, interesting enough, I want you to check this out when you go home. Use either a teaspoon, or it's better yet if you have like a bigger tablespoon. All right, check this out. Take a spoon. And hold your face far away from the spoon and see what you end up seeing. If you're far enough away, if you're beyond C, the center of curvature, okay, then really the case that you're looking at is this case here, a little blast from the past, you know, from earlier on. You know, here's the principal axis, and this is F, and this is the center of curvature. And if the object is out here, remember, what do you get? Not drawn perfectly, but that's the case where you get a real inverted image that's smaller, yes? So you see an inverted image, and inverted images are always real, and it's smaller. So if you go and you look at yourself in a spoon and use the spoon as a mirror, you actually see yourself smaller in the mirror. And you'll see yourself smaller and inverted. However, because you're looking at this case here. However, if you bring yourself, here's your spoon, and you bring your head up really close to the mirror, you know, to the spoon, if you're inside the focal point, now what will you end up seeing? This last case that we just drew, you know, parallel through the focal point, as if it came from C back through C, diverging rays. You get a larger upright virtual image, yes? So when it's inside the focal point, what do you end up seeing? How do you see yourself in the spoon? larger and upright. It's so cool. Hold the spoon far away from you, and you see yourself upside down in the spoon. Bring it in close, and you see yourself upright and magnified. By the way, a lot of guys use a concave mirror like this, and they come in close so that they can see themselves upright and bigger, magnified, so they can do like a better job like shaving or, you know, looking at their skin. And a lot of girls, females, use a concave mirror like this, and when they come in close like that, they could see their skin all magnified, bigger, you know, to put on their makeup and stuff. So you might have like a makeup mirror. And what is that mirror? It's concave. And when you're in close, you see yourself way bigger. But what I'm saying, go home and put the sucker a little bit farther away from you, go beyond C, and guess what you're going to see? You're going to see yourself smaller and upside down. And then you come in closer, whoa, man,